Smarter Development Demonstration. My name is Brian Colbert. I'm an Enterprise Modernization Architect for North America, and I'm joined by Doug Stout and Joseph Gailey, both client technical professionals. And we together will be going through a smarter development scenario utilizing a number of different products. So let's identify the scenario a little bit. This is a common problem for many customers where a production problem creeps up all of a sudden and have to go through the process of identifying where it's coming from, what the problem is, how we need to correct it, etc. Along the way of doing so, numerous people, in our case 3, will play different roles in resolving this particular issue. So we'll have system programmer, analyst, project manager, a number of different developers that are all doing different things with a number of different tools. Now with the Smarter Development Demonstration, we are trying to highlight the total solution of a number of products and not point out all the individual features of every product. You'll see the tight integration that IBM provides with these products, which is seamless and allows easy use of all the tools from within one view. So without further ado, I will turn this over to Doug Stout, who will walk us through what the problem is for this scenario.
Thank you, Brian. My name is Doug Stout, and I'm a client technical professional with the Z-Series problem determination tools. I'll start this demonstration by showing the production problem that needs to be fixed. So right now I'm in the role of a person whose job it is to maintain items that are sold from a catalog order system. Today I'm using an online CICS order application to enter several new kinds of staplers into a catalog file. In this example, I'll enter a blue stapler into the catalog file, and I enter other fields as needed by the program. This application has a problem in that if I don't enter the item correctly, it adds a record to the catalog file with bad data. Notice I don't enter a number into the count in stock field. So it'll add a record to the catalog file with invalid data in that field when I press enter. And I just added the bad record. As the person entering new items, I don't realize that I've just created a problem. But as you'll see downstream, this is a big problem. If this were a movie, you'd hear ominous music playing in the background to let us know something scary is about to happen. But of course, in real life, no scary music. Next, I'll change hats, and I'll be in the role of a telephone agent who's talking to a customer to take an order. I'm using a CICS application to enter and process orders. On the phone, the customer says they want to order a red stapler, which is one of the records that was just added with bad data. I select a red stapler. The customer tells me how many they want. I enter the customer ID, and when I press enter, I expect to see another screen asking for more information about the order. But instead, the transaction adds, and I can't process the order. This is a critical problem because now we have a situation where phone agents can't enter new orders for certain items, which isn't good. As an order agent, I would apologize to the customer and say that we seem to have a computer problem and maybe ask them to call back in a while since we can't enter the order now. But of course, if it were you on the phone and you needed the stapler, what would you do? You probably wouldn't want to call back every 20 minutes. Instead, you'd call somebody else. So this problem in the catalog order system is causing lost business. And this is the problem we'll be fixing in this demo. When an event like this occurs, notification can happen in a number of different ways. You may have Tivoli products that are monitoring your system, and if there's an event, those products can do the notification. In a minute, you'll see a product called Fault Analyzer, which the programmer will be using to research the problem. Fault Analyzer automatically detected the event and collected information about it in real time. As part of its collection processing, Fault Analyzer can do notification, and it can happen in several ways. It can send an email, send a text, or even open and assign a new problem ticket. In this example, a problem ticket will be created manually. Now I'm going to turn it back over to Brian, who will create the problem ticket using Rational Team Concert.
All right, thank you, Doug. So I'm going to talk about RTC. Now, RTC is a collaborative development environment that allows for quite a few different features and functional points. It is a source code management tool, a project management tool, a change management tool, tracks work, potentially tracks time, anything to do with any work in regards to a project. It's a collaborative environment because of the fact that it allows individuals that are not only in the same room or same building, but in different buildings, different cities, different states, countries, etc., to work together on one particular project, and has features and functional points that help allow for that to be more successfully done. So what I'm going to show is a little bit with RTC first prior to getting in and creating the work item. So now in RTC, in our example, we're not going to show every functional point and have a very large project when we go through this scenario. So what I wanted to show before we get into that is an actual project in RTC that has much more information in it that will show a little bit more of the capabilities. So anyone that would like could go to jazz.net and sign up for an account. And on jazz.net, this is an IBM created software framework, and we are developing Rational Team Concert, the product that I'm going to demonstrate, in the open, which means that it is openly available for anyone to go and see what the project plans are, what the potential dates are, what problem tickets are open, who's doing what, who's done what, etc. And so nothing's hidden, well, other than maybe the source code. And with this, as you can see from the screen, there is a number of different project areas that you might have. Now, I brought up the most recent development version, 3.0.1, so this is the project plan associated with that. And what you see in RTC are a number of different dashboards that are tabbed across the top here. So massive amounts of information are stored and provided by RTC, and there is such a thing as there's too much information if it's not organized well. So one of the things that RTC provides is these dashboards with view lists in it that allow you to organize the information that you care about, so that each individual or each group can have their set of views that provide the information that's important to them. So for instance, if you look across any of these, if I look at it, maybe a particular iteration that is being worked on, there are different visual views that can represent the information, like the line and dot charts here. You might have different ones, like APARS, for instance, is just mostly just small queries, but it does have some bar charts in it. And those small queries organize the different types of problems that are currently open, what's been completed, what's is outstanding, etc. And if you look at any of the other ones, 3.0 endgame, as we are nearing delivery of this particular version, you'll notice that the work item comparison, which shows what is open versus closed, what is open versus closed here is many more items are closed than what is open as what you would expect to see. So there's a number of different views that you can create, and these are fully customizable. Now, I did want to show something else within RTC. So if I have a work item and we're going to create one, we're going to create a defect, and so I'm going to go in and open a defect that has some more information in it than what we'd be able to do in our demonstration. So I've opened this defect here, 114744. This defect is a login problem. It has some information which we'll talk about and see in a minute that kind of summarizes that problem. But what I wanted to point out is that part of the collaborative effort here is the discussion that goes on any one of these work items that are out here, whether it's a requirement, whether it's just an enhancement, or it's a defect that needs to be resolved rather quickly. And individuals will participate maybe across the globe in resolving this issue or building that enhancement, but as they do so, they're going to add their bits of information and what they've learned and what they've discovered as they've gone and done whatever research they've done for their piece, and they're going to add that information as points to this discussion group. Now, this is a permanent history of that work item. As you can see, they can become quite large. And in addition to that, they can contain snapshots, screenshots. They can contain additional documentation. As you can see, there's a number of documents in here, as well as links to other information. So any other work items are related to it. If there's a dependency on another work item, either child or parent relationship, as well as if another work item mentions this particular work item, it will also show up. And those things happen automatically. You don't have to go in and do anything specific for those. And as items are completed, they're marked off or crossed off, as you see here. That signifies that this particular work item has either been closed or resolved. So there's a massive amount of information here that is available. Now, what this allows for is a complete traceability and auditability into all the work that is done for a project. So, for instance, if you go and look at the history, I scroll down to the bottom here, you see that Kevin Essler had created this ticket originally and had created an initial description, etc. As you go through here and look at each thing that's done, anything that's done, severity change from normal to critical. You can add yourself as a subscriber if you're interested to see what's going on. If those types of things are automatically tracked in our permanent records, nothing can be deleted. And even if you go in and physically change something, it doesn't just get deleted, it gets crossed off with the new information it's been replaced with. So it does allow you to utilize this information for audit trails as far as what's happened throughout the entire process, and this becomes very handy for that purpose later. So let's get into creating a new work item. So we have a smaller development project here, and there's not much going on here. Our dashboards are pretty plain. We don't have many work items open, and that's not the whole point of this demonstration in the first place. So I'm going to go to work items. I'm going to create a new defect. Okay, so it opens up the defect page, and if I selected a task, for instance, I just want to point this out, the information that shows up here changes. So the information that's required and optional and is displayed depends on the type of work item. So I'm going to select a defect, and we know at this point that there's a production admin with our e-catalog system, and we know that this is the eCat transaction at this point. So I need to file this against something. We're in the Smarter Development project. I'm going to file it against that, so this work item becomes part of that Smarter Development project. I can specify a severity from very unclassified to minor to a blocker, and I'll select blocker for that because it is stopping revenue from coming in. And I'm going to assign ownership. Now, in this case, I'm going to assign it to Doug. Doug will do some analysis, and he'll get into that shortly, but will be the individual that first does some analysis on this, so I'll want to make sure it ends up in his queue. I set a priority. I can plan it for delivery, which I don't really have any planned deliveries. And I could set an estimate and the time remaining, which doesn't make any sense because I don't know anything at this point. I would give a description and review and resolve lab end and leave it at that. And so the team of individuals that are going to work on this are going to start from the point of an admin that happened on a production system with the eCat transaction that is part of the eCatalog system. So I'll go ahead and save this. When I save this, it'll have a defect number assigned to it, so defect 330, and now that is a permanent record available, and you'll notice that it is in a new status. Okay. Now all the fields here are configurable as far as what they're called, what the options are within those, so those can be configured to meet the vocabulary of your particular needs. So I've shown how to create a work item and talked a little bit about RTC. Before I turn over to Doug, I'm first going to turn it over to Joe Gailey, who's going to give an overview of CICS Explorer and talk about the role the systems programmer plays in this particular demonstration.
Thank you, Brian. The CICS Explorer also known as the new face of CICS, is a no-charge Eclipse-based tool available to licensed users of CICS Transaction Server version 3 and 4 to act as an integration point for CICS tooling with rich GUI views. This product has the aim of facilitating new ways to accelerate the transfer of knowledge, skills, and best practices to the next generation of mainframe technical staff, as well as experts who need to maintain productivity and protect service levels. The Explorer and System Z lead the way in platform simplification with a common, intuitive, Eclipse-based environment for architects, developers, administrators, system programmers, and operators. As you can see, we now have a single workbench where we can access all the IBM tools from one Explorer base. Rational tools, RDZ for System Z application development, RAD for server application development, RTC for teamwork collaboration, Rational Asset Analyzer for application analysis. In PD tools, we have APA, Application Performance Analyzer, to do a deep dive problem analysis, Fault Analyzer for reviewing your add-ins, File Manager for accessing your data, Debug Tool for interactively debugging your application. And in the KICS tool suite, we have Interdependency Analyzer, IA for complete inventory of your CICS applications, PA, Performance Analyzer for historical performance reporting, VM, Configuration Manager for all your RDO and CPS and BAS control, Deployment Assistant, DA for creating and maintaining your CPSM environment, MQ for managing your MQ managers, CTG for statistical information about your CICS transaction gateway. So here, we not only have the new face of KICS, rather we now have a smarter development environment. Now, as a CICS system programmer, I've been notified that we have a critical situation in production. I've been informed that the ECAT transaction has abended, and I know we have an SLA penalty for each production abend, so I must mitigate this as soon as possible, disable the transaction. As you can see in the KICS Explorer, I have a KICS-Plex view of production in regions. I have 9 regions. My scope right now is for all 9 regions. I need to identify which of these 9 regions has the ECAT transaction in production. I could narrow down my scope to a specific region, or I can identify which regions have ECAT. Obviously, 9 regions here contain 2,847 transactions. I can filter it down, and I find production AOR 6 to be the offending transaction. At this point, I can do a right-click. I'm given the ability to open it, to look at any attributes, open any related program information, discard it, enable it, disable it, or I can go into my interfaces with other plugins, with CICS Interdependency Analyzer, with the debug tool, or performance information out of KICS PA. But the task at hand is to disable the transaction, mitigate my SLA penalty, and that is done because I am currently running CICS version 4 with full update capability to my environment. So as a system programmer, I would now turn this back over to Doug Stout, my lead developer. He's going to research the add-ins, come up with a root cause analysis. Hopefully we will come up with the fix, test it, and close our work item as soon as possible.
Thank you, Joe. This is Doug Stout again, and now I'm going to be in the role of a developer and use Fault Analyzer to research the abend that just occurred and pinpoint exactly what happened. I'm going to be using RDZ, Rational Developer for System Z, which comes with a plugin for Fault Analyzer. But before I start working with Fault Analyzer, I'll update the problem ticket that Brian created and accept it. This is the Rational Team Concert plugin in RDZ. From here, I can create my own set of queries, and one of them shows a list of items assigned to me. When Brian created that problem ticket, I automatically receive an email telling me that the item had been reassigned to me. And here's a list of my assigned items. I double-click on the one on the top, which is the most recent, and it pops up. I change the status to start working and add a comment saying that I'm looking into the add-end to let people know that I'm working on it, especially since this is a critical problem with many interested stakeholders. In RDZ, you can switch to different perspectives. Fault Analyzer is a perspective in RDZ. Select the Fault Analyzer perspective, and now it's displayed. Fault Analyzer captured information about the add-end and automatically stored that in something called a fault history file. In the upper left, you see a list of different fault history files. One of the nice things about the Fault Analyzer perspective in RDZ is that you can see all of your different fault history files on the various ZOS systems that you use, all in the same list. You may be working on multiple systems, multiple syslexes, even systems on the other side of the planet. And you can configure your view so history files from those systems are shown in one place. To see a history file, double-click on it. A list is displayed down at the bottom of the screen showing all of the entries in that history file. To open an add-end entry, double-click on it, and the add-end analysis report is displayed. Fault Analyzer is a single tool and collection point across all your ZOS environments. Batch, CICS, IMS Online, TSO, DB2 stored procedures, started tasks, just about anywhere an application can run on a ZOS system. Its purpose is to pinpoint where an application abandoned so you can quickly identify the cause of the problem. It shows source-level detail for programs written in COBOL, PL1, C++, and Assembler. By that I mean it shows you the statement where the add-end occurred and displays the values of variables at the time of the add-end. It also gives special detailed information for programs that access VSAM, QSAM, DB2 and IMS databases, MQQs, and other data stores. The whole point behind Fault Analyzer is that you don't have to do add-end processing the old-fashioned way where you sit down with a dump and a program listing and a hex calculator and take hours and hours to try to figure it out. It helps you find the cause of a problem very quickly. It has two interfaces, a 3270 interface that you can access from either TSO or CICS. And there's also an Eclipse plugin that you'll be seeing today that comes with RDZ or can run under CICS Explorer, as Joe mentioned earlier. Running under CICS Explorer gives you a no-cost option to run the Fault Analyzer plugin, since the plugin is free to download and run, as is CICS Explorer. Take a look at this add-end report. First, notice it says there was an ASRA add-end in a program called ECAP35. It makes that very clear, and that's good information right away because now we know exactly where the add-end occurred. As a programmer, if I'm not sure what an ASRA add-end code means, I can look it up. Plug ASRA into the lookup field and click it, and it shows the explanation of the add-end as it appears in the messages manual. That's nice because now I don't have to take more time to find that information. In the report, you see that the add-end occurred when the program executed a subtract statement. And in fact, the reason the add-end occurred was because there was bad data in one of the fields. It flags the field as having a problem. The ECAT record in stock field is numeric, but it contained bad data. Now we know that the program add-ended when it tried to perform arithmetic against this field. I'll copy this part of the report and then select the Rational Team Concert perspective. I'll add a comment into the work item, and I can just paste in the explanation of the add-end. Then I'll save the item. That's good information for my own reference later, since I can keep a running account of what I've discovered about the problem so far in the ticket. Also, anyone can look at the item to see the progress. And now switch back to the Fault Analyzer perspective. Notice that you have these links to the program. Click one, and the program is displayed. One of the nice things about this is that I can quickly see the program and can even see it and the report side by side, like so. Notice in the program itself, we might be able to begin to develop a theory. Here's the subtract statement, and a few lines above it is a read statement. That can raise a suspicion right here that possibly the bad data was read from a record in an input file. We don't know that yet, but we can identify that as a possibility. Take a look at the Advent report in a little more detail. There are different sections in the report that you can select using the tabs on the bottom. Each tab displays a different report section. I click on the Event Summary section. The Event Summary shows the call chain at the time of the Advent. In this case, you see there was a program called ECAT00, which is the main program. ECAT0 called ECAT10. It also shows you system service routines that were in the call chain. Typically, when you do Advent analysis, you don't care much about those, but sometimes seeing them can be helpful because they can indicate certain types of processing. ECAT10 called ECAT30, which in turn called ECAT35, where the Advent occurred. All this is good information because now we know exactly how the application got into the Adventing program, and there's no guesswork involved. Another section of the report is called System-Wide Information. Depending on the type of Advent, you'll see different types of information here. Since this is a CICS Advent, there are lots of details about CICS and the transaction. If, for example, this application accessed DB2 databases, you would also see detailed DB2 information. If it accessed IMS databases, you would see IMS details and so on. For example, here are CICS control blocks. I'll expand that line, and you can see a control block called DFHEIB, which contains a lot of good information, including something called the attention ID. This is the key that the user pressed when they started the transaction. That's good to know. Some other very important information here is the last CICS 3270 screen buffer. This shows exactly what the user had on their screen, including the data that they entered themselves. Having information like the screen buffer and the attention ID can be very important. You know, if you ever called the user and asked them what they were doing just before an Advent occurred, the information they give you is suspect at best. Even though they may try to be helpful, you can still get responses like, "I didn't do anything." And this would be just one more of those cases of magical Advents that produce themselves. But with this information, there's no guessing. Going back to the event summary, and again, this shows you the call chain at the time of the Advent. Click on the link for the program where the Advent occurred. That jumps to the detail section of the report for that program. Here again, you can see the statement where the Advent occurred and the name of the variable that contained the bad data. All of the variables and their values are displayed here. You can see every single variable in the program, working storage, linkage, and the rest. Here I'll search for the variable name, and you can see it in the report. The data is displayed as a value as well as in hex, and you can see that it's defined as a numeric display variable, but it contains binary zeros. That certainly is a problem that would cause an Advent. Notice that this variable is in a record area. That lends credibility to the theory that this data may have come from a record in a file. So let's work with that hypothesis. As a programmer, what I might do next is see if I can recreate the problem in my test environment. If it's possible, I'll make a copy of the production file into my test environment, which I've done in this example. I'll rerun the transaction in my test environment and step through it with a debugger. Fault Analyzer gave me all the information I need, including what the user entered on their screen, to rerun the transaction. I'm going to use a product called Debug Tool to step through the program as it's running. In RDZ, open the Debug Perspective. First, I'll create a profile that'll start the debugger when a particular transaction runs. There's a view in the Debug Perspective called DPCN Profiles that I select. To create a profile, right-click in the view, select Create Profile, and name the program that you want to debug. This is the program, ECAT35, that was identified by Fault Analyzer. Next, save the profile, and the next time that program runs in my test region, Debug Tool will be triggered and will display in my Debug Perspective. Here I'm using a 3270 display that's built into RDZ. I log onto my test region and run the transaction for the catalog order system. and get into the same screen the user was on and try to reproduce the problem. I'll select the red stapler because we know from Fault Analyzer that that was the record that was selected by the user when the event occurred. I press enter, and that causes ECAT35 to run. As soon as it runs, debug tool starts and is displayed on the screen. Here you see the debug tool perspective in RDZ, showing program ECAT35 and stopped at the entry of that program. Debug tool is a single tool you use to debug application programs across ZOS environments, including batch, CICS and IMS, TSO, DB2 stored procedures, Unix system services, and about anywhere an application program can run on a ZOS system. It supports all of the ZOS environments and subsystems. There's no additional cost per environment. It's an interactive debugger and has the features you'd expect to for stepping to a program, setting breakpoints, and monitoring and changing variables. It also has powerful debugging features including automation with scripts, playback, statement tracing, and more. It also includes utilities for code coverage, load module analysis, and COBOL modernization. For the interactive debugger, there are two interfaces, a 3270 interface and an Eclipse plugin. Here you see the plugin running under RDZ, and it can also run under CICS Explorer. As I mentioned, with the Fault Analyzer plugin, the plugin itself is free to download and run, and if you run it under CICS Explorer, that gives you a no-cost option for the GUI. Notice the icons for controls at the top. For example, you can step through the program a statement at a time or run to a breakpoint. From Fault Analyzer, I know where the event occurred, and I'll set a breakpoint at the right place. Notice here's the read statement that we saw, and I'll set a breakpoint just above it. To set a breakpoint, just double-click next to a statement. Breakpoints are shown as icons next to statements, and a list is shown in the breakpoint view. Clicking the Resume button runs the program until it reaches the breakpoint. At this point, we can monitor the variable that will receive the record from the read. Right-click the variable and select Monitor Expression. Now we'll step through the read statement. Notice the contents of the record in the monitor's view. The cat record in stock field is the one to watch since it's where we suspect the bad data. I click the step icon and it executes the read statement. Now take a look at the contents of the cat record in stock field after the read, and sure enough, that data doesn't look very good. At this point, as a programmer, I can be confident that the event was caused by bad data in the catalog file. However, there's still a big problem because we don't know yet how that bad data got into the file in the first place. And that's very important. We can't say this is fixed until we know how that happened. In Debug Tool, you can simply hover your cursor over a variable to display the value in a pop-up. Here I'm hovering over variable ecat file name to see the name of the file that had the bad data, which is eCatalog. Next, I'll reassign the problem ticket to someone who can help us find out what programs update the eCatalog file, since we need to know exactly how that bad data is getting there. I'll switch back over to the Rational Team Concert perspective and make a note in the work item. I'll reassign the ticket back over to Joe Gailey to do that research, and I'll update the status to stop working so management can see the current status in real time, and I save the ticket. Next, Joe Gailey will show you how the application can be scoped using CICS Interdependency Analyzer.
Thank you, Doug. Now, as a junior developer, I've been assigned the task through RTC, as you can see here. I'll bring it up and review the information given to me. I can scroll down, and he says we definitely have a bad data in a file, find out what programs update that particular file. So this is the eCatalog vSAN file. So as a junior programmer, I may not be aware of the application per se. I could be a new hire without the knowledge, or my senior developer could have handed me some outdated documentation for the application. Either way, I'm able to change perspectives and go to the Kix Explorer, utilize Kix Interdependency Analyzer's interface from the Explorer, and I can find out what resources that particular transaction uses. And I get a pop-up of such. I could also go to the perspective for IA and search the same, but I will stay within the Explorer itself, look at my resources, double-click on it, bring it up a little better to read here, and I can see this particular transaction. Information has been collected within the region by Kix Interdependency Analyzer, and it stores that data within DB2 for the power of the query within the relational database. I'm able to retrieve that information from the Explorer, and it tells me all of the artifacts needed for this transaction to run. And as I can see, there's actually 3 vSAM files that are hit by this transaction. And if I expand this twisty for eCatalog, I can actually see every API that has been executed against this file. And he's asked me which particular program in our application does the write. I click on write, and it shows me that ECAD10 actually is the only program that does a write. If the needed change were a copybook change, or if this were a DB2 file and they needed to change the structure of the file, then we'd need to identify every program that would be affected by such a change to identify the scope of that change and not miss any reassemblies for production. I'm able to highlight or click on the catalog, and it shows me every program that accesses this particular file. So, with that knowledge in hand, knowing it's current, I've got ECAD10 as the only writer. So at this point, I can go back to RTC. I can add a comment. At this point, it looks good. I've done my job, and I can reassign it back to Doug. Save it so that it hits his queue now, and I've completed my work. So at this point, I will turn it back over to my lead developer to do an actual determination of bad data within the file itself using File Manager, correct the bad data, followed by fixing, testing, and closing the work for this particular problem. Thank you.
And thank you, Joe. This is Doug Stout again, and what will happen next is that I'm going to actually fix the bad data in the file, and I'm going to use a product called File Manager to do that. So Joe reassigned the problem ticket to me. I'll refresh that ticket to make sure that I have the latest comments and change the status to start working. And I can see Joe's comments down here. All right, in RDZ, I'm going to bring up my ZOS projects view, and in here there's the Systems Information tab that is the File Manager plug-in. And so at this point, I'm worried that, depending on your organization, could be a programmer, could be a production control person. Since this is a critical problem, we want to get that data fixed and get the application up and running again. So I'll directly edit the data in the production file to do that. So I double-click on the file name, and the file pops up. So here's the file, and really all that I have to do is locate the bad data and then overtype the bad bad data with some number. It'll be valid, and I can see that the bad data is in here in a few different places. I have a few of the different staplers that were entered, so I can fix those, and that's really all there is to it. File Manager itself is, again, a single tool set that's used to work with a broad spectrum of ZOS files and databases. File Manager can access VSAM, IAM, QSAM files, PDSs, and libraries, DB2 and IMS databases, HFS files, even OHAM files, CICS queues, WebSphere MQ queues, even tapes. Access to all of these is included in File Manager, and there's no additional cost to add features for the different types of data stores that you want to access. The primary functions are the editor and viewer, and you just saw an example of the editor. And a very important feature is that you can edit a file of any size. You can have millions and billions of records, not a problem. You can edit those files directly. In addition to the editor and viewer, there's a full complement of very powerful online and batch utilities for copying, extracting, load, create, compare, print, and many, many others. There are two interfaces. There's a 3270 interface that's accessed either from TSO or CICS, and you've seen the Eclipse GUI interface, which is a plug-in to RDZ or CICS Explorer. So I'm done editing this file. I'll just click the X to close it. It asks if I want to save the changes, and I will. Very good. So at this point, we've actually determined what caused the problem. We know which programs update the file that had the bad data. We've fixed the bad data at this point, and so we can start using that application again, and that's good news. What I'll do next is reassign this to a programmer to actually fix the program that writes the bad data so that it doesn't happen again. I'll assign this back to Brian, and I'll add a comment. To please take a look at the program. So I reassigned it. I'll mark it as stop working, and that'll notify Brian that he will take the next step and actually modify the program so that it doesn't write bad data into that file anymore.
Well, thank you, Doug. So this is Brian Colbert again, and I'm going to go through the process of fixing a problem as a developer. I'm going to utilize RDZ, Rational Developer for System Z, which you've already seen a number of times, and Rational Asset Analyzer. So let's talk about RDZ. RDZ, Rational Developer for System Z, is a GUI user interface for doing Z development. So COBOL, PL1, Assembler, CICS, IMS, etc. So anything on Z you can just about do within RDZ rather than going to TSO, ISTF. You still have the ability to have an integrated emulator so that you can get to certain things, like get the CICS transactions you might want to test from within it. But much of the connectivity that you would normally access through TSO, you can now access through this drop-down tree structure where it shows you what your MVS files are, be able to get to the individual data sets, PDSs, and the individual members within those PDSs, as well as be able to view and review your jobs that you've executed. So, for instance, here's a job I've executed, and you can get the output and be able to scroll through and look at the output for that particular job. So those are all very nice to be able to have and access. Now, RDZ allows you to create projects that represent files that are actually stored on the host. And so this local project here was actually copy or cut and paste and a drag and drop feature from within RDZ into that particular project. So if I wish to add another member here, I can simply drag and drop it to that project, and it shows up, and now I can access as well as be able to open and edit within the editor. Now, the problem at hand is to find out where the data is being written bad in ECAD 10 And within RDZ, as Joe and Doug have already showed you, you can access your work items. So I would go into my work items view, open up my work, and you'll notice that the production admin has been reassigned to me. I would select that, notify everyone that I am starting to work on it. I'd add a comment that working on a fix, and save this so that everyone is then updated that I do now am working on fixing that. Now, at this point, I need a better understanding of what's going on, and we've shown a number of different integration points within RDZ, and I want to show one additional one. There's a product called Rational Asset Analyzer, which you use to create an inventory of your enterprise applications. So your batch JCL, your CICS and IMS transactions, your programs of a number of different languages, as well as your data structures in DB2, your DD statements, how they're defined in JCL, etc. All these things are scanned in during an inventory process. So we have an interface, in this case through a browser, that allows us to go and review what has been inventoried. Now in this case here, we're really only interested in the MVS assets, but we also allow scanning of distributed assets as well as web services. So I'm going to open up MVS assets and just show a little bit here, and then I'll show this in another way. Now, if I'm an analyst or a developer, I could utilize this browser interface to learn or get application understanding, which is one of the main functional points. The others are impact analysis and business rule mining. So application understanding allows individuals that are in different roles, system programmers, developers, DBAs, analysts, project managers, etc., to go in and get understanding of applications. Now, their starting point might be different. So one individual, for instance, a system programmer, would most likely know and understand the transactional view, but may not understand the programs or the data. And so his starting point would be the transactions. A developer usually spends most of his time in doing maintenance and creating new programs, and to be most familiar with the programs and the maps and the things that connect to those programs, but may not be all that familiar with the data or the transactional structure. And a DBA, somebody that manages the data, would be more familiar with the DB2 columns, DB2 tables, the data sets that are utilized in an application. But from any one of these starting points, you can get to the information of the others. So I can start at a program, and from a program, if I look at ECAD 10, for instance, which we'll be looking at, I can understand what copybooks are used, if it's used in batch jobs, if it calls anything else, or is being called by other programs. So in this case, other transactions are actually executing it, and it's not calling any other programs. But then it does things, it shows what data sets you're accessing, or data stores. So you have CICS transient data queue, debug transient data queue, as well as the eCatalog CICS or VSAM file, and that's the one we're obviously interested in. So there's a lot of information you can gather from here. Now, there's many more things I can show in here, especially the impact analysis, but it's kind of beyond the scope of what we want to cover. But what I did want to show is how you can also interact with REA from within the RDZ environment. So now I'm back in RDZ, and I'm in my project here, and this project represents the eCatalog application. And as I was told in my work item here, that I need to update program ECAD 10, that this is where it is writing to this eCatalog file. And so one of the things I can do is I can open up this file, ECAD 10, and start looking through it and see what I can see and do searches and such. But one of the other things I can do is I can right-click on this. Because I have this scanned in Asset Analyzer, I can utilize the Asset Analyzer integration function within RDZ and be able to utilize the information that was gathered during the REA inventory. So I can understand what the dependency files are for doing a build. I can understand what data elements at a high level are included and be able to expand and look at those. And I can look at control transfers from within here if it's doing any control transfers. And I also can understand what data it's accessing. Now, as a developer, I may or may not be very familiar with this program, and there's some visual references that you can access to help with that. So one of those is the show control flow diagram. Now, the control flow diagram, what this does is to give you the relationship and the call execution of the paragraphs within your program. So we know that ECAD has a mainline paragraph in its procedure division, and it's calling these particular paragraphs in order. And from within here, if I actually go back out, expand this a little bit, one of the nice things about this, say I don't even have the source code open, I can look at one of these paragraphs and say, well, I'd like to understand more about this. I see what the flow is. I can click on that. It'll go and open up the source code to that particular paragraph. So what this allows you to do is have a visual overview of the program and how it flows, and be able to step into the individual paragraphs as you're understanding that flow, and be able to see what source is actually within these statements or within each individual paragraph. And so that can be very, very helpful, especially for new developers or developers that are new to a particular set of programs in an application. Now, one of the other things that's very useful in this case for understanding how this CAT record in stock that was identified as the culprit in having the bad data in it, it's nice to be able to understand where that's actually used and modified and referenced. So I can select Show Data Element Table, again from the Rational Asset Analyzer interface, and it gives me a list of all the variables that are utilized in this program. And there's the CAT record in stock that has been specified and listed in the work item as the culprit. And I can right-click on that and say I'd like to do a find on references and modifications. And it's going to give me a list down here of any instances found. Now, there's only one instance here. So if I double-click on that, it opens up the source and navigates to the point of where that's being modified. And so what you can see here is that a move of the add stock input field is being added to or moved to this CAT record stock. So this is the only place in the application where this field is being written to that VSAM file. So we know that the problem has to be here. Now, this add stock input field is tied to a particular map. Now, and that tells me, and the reason I know that is because if you look at the field, it's got the I on the end of it, and being familiar with the program, I know that that's one of the input fields coming from the map. And this has obviously been causing a problem. So one of the things I want to do is look at the source and figure out, well, why are we having this particular problem with the data? As you can see, we're checking to see if it's numeric or not. If it's not numeric, we're setting a message and we're falling out of the if statement. But as you notice here, the one that's following it is actually checking the on order field. It's checking if it's not numeric and it's moving an error message, but it's also setting a flag. So at some point in time, the developer here forgot to also place that flag being set after the error had been found from the reading the input or the invalid data coming in from the map. So I can copy that field up there, and that in essence will fix the problem. But we need to go through the process of testing and verifying that that is actually the case. So I've saved this, and before I get out of here, one of the other things I wanted to show, within RDZ there is the ability to do content assist. The content assist is one of those nicety things that happens that allows you to bring up a list of verbs that you can actually execute within the context of the language you're working in. So say I'm going to do a move statement in here, so type an M and hit Control Space Bar, and it shows me variables that start with M. as well as any verbs that start with them. So I can select the move. And what this does is allow you to walk through building a statement. So if I'm looking for this add stock, or add item to program, I can walk through creating a statement. What this does is eliminate a lot of typing errors, as well as make it easy so that you don't have to go back up and forth in the copybooks or into the working storage area to remember what the variable names are. So that's just a little more on RDZ. So I saved this member. Now I'm working locally. Now I'm going to deploy this to a test region, and so one of the things I want to do is go back to my PDS member here on our system in Dallas, and I'm just going to drag and drop this updated module that I updated locally. I'm going to copy that and overwrite what's in my personal PDF for this application, and now I have it on the system Z. Now with RDZ, one of the other things I can do is generate JCL for compilation and linking. So I can select Generate JCL for compile and link, and it specifies what data set is it'll put the JCL, what the job name will be called, and what the member name within that data set will be called. I'll select OK, and that will go out and generate, and it's generated and placed it in there. And now it says, would you like to submit it or open it, or just go on and continue and select OK. I'm going to open it, and I wanted to review quickly what is in here. So we have a compilation and a link that is done for this particular program, and this is done via the operations in the settings that are set in the preferences, so it knows where my libraries are. It knows where I should be putting the load module. So if you look here, the load module is actually going into our CICS7 region, which is our test region. And I can go ahead and execute this. Okay, so just by typing SUB or submit, it tells me that it's job 9781, and within RDZ I can access JES. So I can go down to the JES view and refresh this. And there's the 9781 job. I can double click on it to verify that they're actually executed correctly. I've got a return code of 04 and zeros on the link, so that looks to be fine. Now, you can also, from within RDZ, access some other functionality within the CICS Explorer. So I can go into the CICS Explorer, go to the particular program, right-click on it, and do a new copy so that that new copy has been loaded for testing purposes now. Now, again, from with RDZ, I can open up an emulator, sign on to that test region, and execute the transaction. Now, Doug showed at the beginning when he showed the problem that you went through the process of executing the ECAD transaction to create the entries in the catalog, and the ECAT transaction to order entries from the catalog. So I'm going to start up with the ECAD, and I'm going to add a new item, and I'll call this 611, and give a description of the pink stapler, go to apartment, and the cost, let's see, pink staplers are awful expensive, and I'm not going to put anything in the stock like Doug had done originally, and I'll add some on-order value to it and press enter. And now what you see is that it's saying, well, you need to enter a stock quantity, so it's preventing that bad data from being written. So I come back up in here and add some initial stock quantity and press enter, and it does add that record. Now from here, I can then go to the ECAT transaction and look for that pink stapler, which will be down the ways a little bit, 611 at the bottom here. And, well, apparently I entered the cost of it incorrectly. And I can order this particular stapler 5 of these and add a customer information, and you see that the order was successfully placed. So in test now we have fixed the particular problem. We have verified that both the bad data is now not being written, as well as that a new item can be ordered successfully without an append. And I can now go back and update the RTC entry and work item to reflect this. So in here, okay, so I'm going to add a comment here. Fixed ECAD 10 and have deployed and tested to the test region. Now, I did want to show one other thing here within RDZ and RTC. Now, I've added this comment, but one of the things I did not do and take advantage of within RTC is the ability to say, well, I'd like to capture a picture rather than just type in or cut and paste some comments. So, for instance, if I was looking at that source code and that source code had in it the original error that we had found, I go back and find that error. One of the things that I might do is say, well, I want to take a snippet of the source code. So if I deleted that source member out of there temporarily, I can say, well, I'd like to add this to that record. And it knows that I started this from that particular work item. I can add it to that work item. And now within the links tab, you get this snapshot or screenshot of what you captured. Now you can do this with any screen or any information you wish to capture. So those things that you can't very easily capture through a cut and paste or drag and drop within your Windows or your browser or your different environment, you can very easily just take a snapshot of it and include it. And that also goes for additional documentation. You can link documents to it and so on. So we've completed the fixing of this particular problem and have updated the record, and what I would do now is go ahead and stop work on this particular record and say to save that, and then I would also say that this problem has been resolved. Now we would also go through the process with RDZ and or RTC and actually deploy this particular fix as an emergency fix using a defined process in RTC and deploy it to the production regions where it was required. And again, that is all integrated into the environment. So what we've done here, we fixed the problem in RDZ after analyzing with the REA and REA interface within RDZ. We've deployed and tested it on the test region, and we've updated and closed out the particular RTC entry. The only thing we haven't done is the actual deployment to production, which is outside the scope of what we want to demonstrate. So in summary, we have gone through and showed an integrated solution where we've identified a problem, had seen been notified through Fault Analyzer, have created a work item to track all the work from beginning to end through Rational Team Concert, have utilized CICS Explorer to understand the application and be able to disable the transaction in production, utilize Fault Analyzer to research the append and gain valuable information that we would not very easily be able to ascertain otherwise. We utilize the debug tool within Rational Developer for System Z to understand the actual problem itself, where the error was occurring, and validate that it was bad data. We use CICS Interdependency Analyzer to understand where that data was written from and verify that we are covering all bases and narrowing down where the bad data came from originally. And then we use File Manager to go and fix the data in the VSAM file. We finished up fixing the problem with Rational Developer for System Z after doing some initial analysis with Rational Asset Analyzer, and of course tested the fix with Rational Developer for System Z and closed out the work item in Rational Team Concert, where we also gathered some other additional information, which now we have a permanent record of everything that was done here. We We also demonstrated a complete solution where a number of individuals in different roles can participate in one process and one workflow and successfully and productively complete their day-to-day job. So we appreciate your time and thank you for joining us and hope you enjoyed the demonstration.